Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to have the input as well as concurrence regarding the quality of video as well as audio. If it is perfect, just write perfect over the live chat and then we are ready to go ahead. Anyways, the agenda behind today's video is being polar as well as Nyquist form of the stability. So in yesterday's class, I was keep asking which are the different topics where you guys find little bit difficulty. So I have got the 2 or 3 inputs as the Nyquist as well as polar plot. So you can say from today onwards, we are going to start the polar as well as Nyquist plot. Anyways, keeping aside each and everything where the Nyquist has been the extension of the polar plot, the today's class is almost gonna be the basics of the magnitude as well as the phase provided by any given transfer function into the frequency domain. Could you understand what I'm saying? So the agenda behind the today's video must be very precise and clear to all of us. From today onwards, we are going to start one of the very important topic within the control system, and it had been a topic where many of these students used to have a good amount of doubts. Specifically not in polar, once they go in Nyquist, once they talk about the gain margin, phase margin, similarly they talk about the stability because of the encirclement of -1 plus J0, anti-clockwise encirclement, clockwise encirclement. There are several good amount of details are being attached with the Nyquist as well as the polar plot where many of the students used to have the doubt. Could you understand what I am saying? So put the heading from today onwards, we are going to start the polar plot, but within the polar plot, we are going to discuss about the gain as well as the phase which would be provided by the given transfer function which would be dependent on frequency. What does that mean of it? That means we are shifting our domain of study from Laplace to frequency. Could you understand what I am saying? The polar plot as well as Nyquist plot had been drawn over the omega plane. We would call it a j omega plane. That means the s has to get replaced with the omega. What I am saying, the control system which we have been looking in had been based on the concept through the question, so I would not be going into the much detailed part of the theory and all, but still few of the little idea if we'll be having in periphery, the things would be much easier. Piccola Basu, the root locus you are saying, probably once the Nyquist as well as the polar plot is going to get over, definitely I am going to take the root locus. And as far as the difficulty is concerned, I would keep the root locus is being comparatively simpler than the Nyquist as well as polar plot. So put the heading as polar plot. So we are going to start with polar plot. Yes, within the polar plot, the specific topic which we have been focusing in is being I would talk about how much gain would be offered by the transfer function. Gain would be offered by the transfer function in frequency domain. I would say the gain offered by the transfer function. Once we are done with the gain offered by the transfer function, we would also focus over the phase offered by the given transfer function, obviously in frequency domain again. Phase offered by the transfer function in frequency domain again. So let me take few very simpler form of the transfer function and we would try to get its transfer function as well as its magnitude. Agreed? So let me take the firstmost problem, and here goes the firstmost problem. And let's take the problem had been 1 plus of st1. May I know how much gain would be offered by the system over the frequency domain, and at the same time how much phase would be offered over the frequency domain. So as it has been the study over the frequency domain, now it's the right time to replace s with j omega. So whenever you had to draw the polar plot or the extension of the polar plot, which you call it Nyquist plot, the s has to get replaced with the j omega. So here it becomes 1 plus sf replaced with j omega, and here it goes t1. So we had been focusing over its two factor. The first part had been its magnitude. So I had been talking about the magnitude of t j omega. Once we are done with this, we had been focusing over the phase which had been offered by the system on frequency domain. Tell me how much gain would be offered by the system. See, You could have seen this thing in probably class 11th when first time the concept of complex number had got introduced or the complex variable had got introduced. May I know how much magnitude would be provided by this factor? It had been the real part, it had been the imaginary part. So obviously its magnitude is going to be root over of real part plus of imaginary part, squaring of both, squaring of both. So as far as the gain which would be provided by this transfer function is been 1 square, and here it goes omega t1 which has been raised to the power of 2, which has been raised to the power of 2. Could you understand what I am saying? In the same sequence, if we will talk about how much phase shift would be provided by the system, so simply the phase which would be provided by the system is supposed to be dependent on frequency is simply gonna be tan inverse imaginary part. What had been the imaginary part over here? It's been omega t1, and similarly real part, and that had been 1. That had been 1. And one additional information I would like to give. Tomorrow had been the examination for the engineering services examination. So who are all had been sitting or appearing in tomorrow's ESE examination, all the very best for them. And probably tomorrow we are not going to have, at least my subject is not going to have the live in tomorrow's class, because we had been planning for a complete question solution in tomorrow's class. Probably we are going to get live on our main channel precisely at 6 p.m. tomorrow. So the second paper, the complete solution would be given around 6 p.m. and at the same time the aptitude and I can say non-technical part, which paper had been taken as a paper number 1, there we are going to live at around 2 p.m. 2 p.m. Agreed, no? So we are going to have the session tomorrow, and probably we won't have any session for a control system which we used to have in the regular basis. So tomorrow we are not going to have any session for the control system. Agreed? Now I would like to have the next question. The next question do come over here. Let's take the question had been 1 minus of st1. Similarly, the third question which we have brought over here, it's been minus 1 plus of st1. And the fourth question which had been brought to you guys is been minus 1 minus minus st1. As far as the magnitude is being concerned, you could understand very well. So the magnitude had been very same. Either you take the reference of 1 plus st1, either you take the reference of 1 minus st1, minus 1 plus st1, or minus 1 minus st1. The magnitude would remain very same. But one thing has been quite sure, the angle which would be provided by either of the transfer function is supposed to get change. So we had to focus more over its angle, how much angle would be provided by the second, third as well as the fourth transfer function. May I know what would be the gain which would be provided by the second? Obviously the gain would remain same. There would not be any change in gain. Why so? Because the gain or the magnitude offered by this complex variable is being square root of the squaring of the real part plus of squaring of the imaginary part. Squaring of the real part, my dear friend, real part had been 1 earlier, now it had been changed to 1 minus 1 minus 1. That means still once you will take the square of 1 or either minus 1, still the value would be very same. That's the first thing. Secondly, if you will take the square of the imaginary part had been positive as well as negative, but its magnitude had been same. So if you take the reference of this or this, obviously still you have been getting the factor of minus omega t or plus omega t, and once it will be raised to the power of 2, the magnitude is not supposed to change. Magnitude is not supposed to change. May I know what would be the angle which would be offered by the option 2? Whenever you have this sort of problem, no, you just try to locate 1 minus of st1. S could have been replaced with a j omega. So obviously it's going to be 1 minus of j omega t1. The real part had been positive, imaginary part had been negative. So real part had been positive, imaginary part had been negative. Somewhere here it has been. Somewhere here it has been. May I know what would be its base? What would be its perpendicular? This is going to be its perpendicular. Worth had been omega t1. And similarly this has been the length of its base. And it had been 1. It had been 1. And if we'll talk about this angle, no, my dear friend, so far the angle had been measured in anti-clockwise direction, but first time the angle has been measured in clockwise direction. What does it mean of it? That means the angle would be counted negatively. What does it mean of it? That means first you put minus over here because you have been calculating angle in the clockwise direction. That's the first thing. And at the same time, if we'll talk about the worth of the angle, it had been tan inverse of the perpendicular. Perpendicular is going to be the imaginary part. It's going to be omega t1, and similarly divided by the real part, and that had been 1 itself. So if we'll talk about how much angle which would be given by this system is simply going to be minus times of tan inverse of omega t1. Minus times of tan inverse of omega t1. Agreed? In the same sequence, if I take the question number 3, how much angle would be provided by the system? Again, you had to do the same process. Which process has to be followed? First, focus over the real part. The real part had been negative and the imaginary part has been positive. What does it mean of it? That means this point had been lying somewhere here, and the thing must be very clear to all of us. Whenever the angle is being measured, always the reference is being taken as positive sigma axis or positive real axis. So in two different ways the angle could have been calculated. Either I can go into the clockwise direction, either I can go into the anti-clockwise direction. Yes sir, we can do so. Okay, then in that case what we have been doing over here, let me calculate this angle first. May I know what would be this angle? This angle is simply gonna be theta, and this could have been written as tan inverse of vertical part. The vertical part had been what? Omega t1. Vertical part had been the omega t1, and similarly real part had been 1. So simply this angle which had been offered by the system is been theta, and that had been tan inverse omega t1. So may I know what would be the system solution? Obviously it's simply gonna be 180 minus of 180 minus of tan inverse of omega t. 180 minus of tan inverse of omega t. Yes. Let me do one thing. Let me take few number of problems, the very basic problem, and we would try to learn, or I would try to judge how far you guys are able to digest the complete concept. Tell me how much angle it would have. 1 minus of j, minus 1 plus j, minus 1 minus j, 1 minus j. Tell me what had been the magnitude of the individual complex number and how much phase had been provided by the individual complex number. Individual complex number. I would like to have the input from each one of you. How much gain? Obviously the gain is going to be root over 2 everywhere, but how much phase shift would be provided by either of the system? What would be the phase shift which should be provided by the system number 1, system number 2, system number 3, system number 4? I would like to have the input from each one of you. Tell me. Sir, first and last function is same, sir. Let me check it out. First and last, yeah. First and last had been same, so we can do one thing. We could have written this as minus 1 plus of j. Tell me how much angle would be offered by the system number 1, system number 2, system number 3, system number 4. Forget about the magnitude, because the calculation of the magnitude is still a very easy task to deal with. But I have seen in my teaching career, most of the students find the Nyquist as well as polar plot bit difficult because they do not have much idea how to extract the actual angle which would be offered by the individual transfer function. You can write this as plus 1 plus j. Tell me how much angle would be offered by the first system. So the answer have started coming. As per the Picorub, for the first angle would be minus 45 degree. So let me focus over the first question first. Let me draw the S-plane. Here it had been the S-plane. It had been the real axis of the S-plane. It had been the imaginary axis of the S-plane. As far as the real part is being concerned, the real part is being pure positive. It has been positive somewhere at 1. And if we'll talk about the imaginary part, it had been negative. So obviously it would go down. It's been at minus 1. The intersection point would come somewhere over the fourth quadrant. And if you'll talk about this angle, no, so as you have been taking the reference of positive x-axis, but your movement had been in anti-clockwise clockwise direction, so obviously it would be measured minus how much angle it had been. It's gonna be the perpendicular divided by base, put together is gonna be minus of 45. I have seen many of the time the student, what they do, they would minus, they would take, and thereafter what they would do, tan inverse of perpendicular, sir, perpendicular had been going downside, they would take minus, and then they would say the sir base side had been going towards right hand side, so it would be +1, and end of the day they would calculate the angle as minus, and minus they would be cancelling out, and they would be writing the angle as plus 45 degree. No, what I am saying, the imaginary part was negative, that is why the point had been located in the fourth quadrant. That means those consideration is already been taken. What I am saying, those consideration is already been taken, but this minus sign should not be used. So I would say the first mistake where the many of the student do, and that's nothing but once you are done in which quadrant the particular point has been kept in, you just take the magnitude of the perpendicular, you just take the magnitude of its base, then only you would be able to get its best known answer. Yes. So the angle which had been offered by this system is been minus 45 degree. There is no doubt as such. If I take the reference of second question, the second question where the real part had been negative, obviously either it would be in second or the third quadrant, and imaginary part had been positive. What does that mean of it? That means the point is being kept somewhere here, somewhere here. Again, what we are going to do, we are going to connect this point to the origin, and all the way from the positive sigma axis I would take either the anti-clockwise path or the clockwise path, and from there I would try to get its angle. I would try to get its angle. So here it's gonna be minus 1 plus of j, minus 1 plus of j. The best way could have been calculate this angle first. Let's take it the theta and subtract with the 180 degree. So 180 degree is already been there. Yes, sir, 180 degree is already been there. May you know what should be its angle? It's gonna be perpendicular divided by base. Perpendicular is gonna be 1, and base, nobody should write the base as 1, minus 1. I have been talking about its magnitude, so the magnitude of the minus 1 would again be plus only. So the worth which we have been getting out of it's been, how much it is? 180 is going to get subtracted with the 45, you would be getting 135 degree as output. 135 degree as output. In the same sequence, if I take minus 1 minus j, minus 1 minus j would come somewhere here. So in the two different way you could have measured this angle. If you'll take clockwise direction, the angle is gonna be minus of 135, and similarly all the way if you have been taking the anti-clockwise direction, the angle is gonna be 225 degree. Many of the students used to have doubts, sir, should I be taking minus 135 or should I be taking 225? Both had been precisely very same. It's your choice. What I'm saying, it's your choice. It's completely your choice. It's completely your choice. In the same sequence, let me take the next question or the next transfer function. Let's take it's been the fifth transfer function, and the system had been 1 plus of j. May you know how much angle would be offered by the system? Forget about the magnitude. Tell me how much angle would be offered by the system. 1 divided by 1 plus of j. In the same sequence, let me move forward. Let me take the next question, and that had been 1 divided by minus 1 plus of j. How much phase shift would be provided by this system? In the same sequence, let me take the question number 7, and that had been 1 divided by minus 1 minus j. How much phase shift would be provided by this system? How much phase shift would be provided by this system? And even if you want, you can take the question number 8 also, where another change had been introduced, and that had been 1 divided by minus of j. Start giving answer sequentially. You can put the answer for the 5th first, then 6th, then 7th, then 8th. Tell me how much angle would be offered by the question number 5. How much angle would be offered by the question number 5? My dear friend, the approach remains very same. Until and unless the real part and the imaginary part is not known, until and unless the sign associated with the negative, real as well as imaginary part is not been known, obviously you may not be able to locate the angle which would be offered by this transfer function. Which would be offered by this transfer function. Tell me, what would be the actual angle? What would be the actual angle? What would be the actual angle? So maximum 5 minutes I would give to you guys, and within 5 minutes you must be able to smash this problem out. How much face would be provided by the question number 5, question number 6, question number 7 and question number 8. Question number 8. See, the answer have started coming. As per the Picora, answer is been minus 45, minus 135, 135, 45. Do one thing, you had to have the basic understanding of method of factorization. How the factorization would be done? You had to multiply numerator and denominator with the complex conjugate of the denominator. I repeat, you had to multiply with the complex conjugate of the denominator. What does that mean by the complex conjugate? The complex conjugate of any of the complex number is the multiplication between the same number, keeping or changing the sign of the imaginary part. So here it's been 1 minus of j. Towards denominator side, what happens? You always be getting a positive number. You would always be getting a positive number. Could you understand what I am saying? So here it becomes 1 plus j, 1 minus j. It would become a square minus of b square, where the j square is nothing but the minus of 1. 1 minus of minus 1, that becomes 2. So this has been plus of 2. So what I am saying, whenever you take the conjugate, no, towards denominator side, whatever you get, no, would not have any effect over the angle, because the factor which we are going to get towards denominator side is going to be pure real. Not only that, it would be always positive. Whenever you multiply any of the complex number with its complex conjugate, now the result would be real as well as pure positive. And as the number is been pure real and pure positive, one thing is been quite sure, it has not been your area of concern at all, because of plus 2 there would not be any introduction of the face itself. So you can say 1 minus j, how much angle or how much phase shift which had been provided, no, the same phase shift is being provided by the 1 upon 1 plus j. So 1 minus j, how much phase shift is being provided? It's simply equals to of minus of 45. I know many of the students used to by heart, if the function do come towards denominator side, we used to multiply with the minus sign, but that factor is not always correct. That factor is not always correct. Could you understand what I am saying? In the same sequence, if we have been focusing over the question number 6, magnitude, obviously if we will talk about the magnitude offered by this system is being 1 upon root over minus of 1 has been raised to the power of 2 plus of 1 which has been raised to the power of 2. Put together is going to be 1 upon root 2. I am not focusing over its magnitude, let me focus over its phase. How much phase would be provided by this system? Tell me. How much phase would be provided by this system? Again, the same methodology has to be used. What I am saying? Again, the same methodology has to be used. What it is, sir? The given system is being 1 divided by minus 1 plus of j. You had to multiply with its complex conjugate, sir. Minus 1 minus j. End of the day, what had been happening, whenever there had been the multiplication between the complex number with its complex conjugate, the result would be pure real positive number. That means whatever the factor is going to come towards the denominator side is nothing to do with the angle, only and only focus over the numerator. And as far as the numerator is being concerned, the numerator had been minus 1 minus j. How much phase shift it is going to provide? The phase shift which would be provided by this system is simply going to be either in the anti-clockwise direction, you could have taken the angle as 225. In the anti-clockwise direction, you could have taken this angle as minus 135. Agreed, no? So that is why I used to say the student used to by heart the things. Student used to by heart the things. What they would think, sir, minus 1 plus of j, minus 1 plus of j, how much angle we had? 135. If we'll go towards, no, you should not by heart those things. You should not by heart those things. In the same sequence, let me take the question number 7 and I would raise the same thing. How much phase shift would be provided by the system? Again, the same process has to be followed, and I would tell to all of us, you need not to do this thing again and again, no, because you had the fair idea now. You had the fair idea now. Towards denominator side, you would be having the real part. You would be having the real part. Just a minute. Towards denominator side, you are going to have a positive real part, and towards numerator side, you would just be having complex conjugate part. Complex conjugate part. So may I know how much angle would be offered by minus 1 plus j? Obviously, sir, this could be the next problem which can be raised. Minus 1 plus j. Minus 1 plus j is going to offer the angle as 135 degree. So you can say, sir, here the expected angle is being 135 degree. Expected angle is being 135 degree. Agreed? In the same sequence, if you talk about 1 upon 1 minus j, the same thing do happen. Once you'll take is complex conjugate got multiplied towards numerator as well as denominator. Towards numerator side 1 plus j would go out, and the angle which we are supposed to get, it's been 45 degree. It's been 45 degree. So I think you could have related why the angle for this many transfer function is being calculated early, and why this many transfer function has been brought in to take its angle. Now let me take the next question. I would like to ask the next question from each one of you. 1 plus j, 1 minus j. How much phase shift is going to get provided by this factor 1 plus j divided by 1 minus j? I would like to have the input from each one of you. How much phase shift will be provided by this system at a certain operating frequency? Let's take the frequency had been omega. Frequency had been omega. Tell me, how much angle would be offered? So Kundan Kumar says the answer would be 90. Anyone else apart from the Kundan Kumar? Anyone else? Again the same process has to be followed. What I am saying, you did not to focus here and there. Again the same process has to be followed, and from there you would try to get its best most answer. How much angle would be offered by this system? 1 plus j divided by 1 minus j. And you can assure, if you have a little bit relativity how the angle is being extracted for this many given transfer function, probably you would start learning the basic concept of the polar, Nyquist as well as Bode, because there frequency versus phase plot had been drawn into the different ways. 90. People are saying the answer would be 90. Let me see how. Again the same process has to be followed. What I am saying, you need not to worry at all. Again the same process has to be followed. And what's going to be that process? My dear friend, I would multiply numerator and denominator with the complex conjugate of the denominator, and that had been 1 plus j and that had been 1 plus j. And once you multiply 1 minus j with the 1 plus j, the result used to be 2, and the 2 is been positive and pure real. Because of that, there would not be an introduction of the angle at all. Agreed, sir? So the factor which had been left out towards numerator only and only are the factor which are going to introduce the angle. May I know what are the factors they had? 1 plus j and 1 plus j. One of the best thing, I repeat, one of the best thing with the angle is being, do you know or not, if you have the first complex number is getting multiplied with the second complex number, getting multiplied with the third complex number, if you will try to calculate how much total angle is being offered by the system, it's just been the angle offered by the first plus of second plus of third. That means 1 plus j is getting multiplied with 1 plus j. So total angle would be offered by this system is gonna be the angle offered by the 1 plus j and angle offered by the repetition of 1 plus j. And as we know, the angle offered by the 1 plus j is been 45, and again the another angle 45 degrees being offered. Put together is simply gonna be 90 degree. Many of the students may also have doubts, sir. Can you prove it? Yes, we will try to prove it. See, what had been happening? It had become 1 minus of j getting multiplied with 1 plus of j. Yes. And put together this factor had become 2, which will never be remembered in future. And towards numerator side it had become 1 plus j, which has been raised to the power of 2. And once you'll take a plus b to the power of 2, which had been a important identity which we have seen in class 8th and as well 9th, it becomes 1 has been raised to the power of 2, that's a 1, plus of j has been raised to the power of 2, that had been j square is nothing but minus of 1, and end of the day the result what we supposed to get is going to be 2 times of a into b, and towards denominator side again we had the factor of 2. We had the factor of 2. See, 1 and minus 1 is going to go out, and the factor which has been left out is being pure j. What does that mean by the pure j? If you would like to locate the j over the S plane, you yourself would be able to understand it's been the pure real axis, it's been the pure imaginary axis, and this point had been kept over the only and only j omega axis, and that too in the positive side. How much angle it had been? 90 degree. Has it been plus or has it been minus? It's been plus. It's been plus. So what I'm saying, we used to by heart this. We used to by heart this outcome, but you need not to by heart this outcome. You just have faith on this outcome, that if the complex numbers, so far it had been the complex number, in future they are becoming complex variables. Like you can have the factor of 1 plus st1, you can have the factor of 1 plus st2, you can have the factor of 1 minus st3. If they had been multiplied together, no, you should not give any second thought. You can just calculate the angle offered by this. That's it. That's it. So the answer which we have got so far from the Kundan Kumar, the answer had been 90, and DS is stating the answer had been 90, Pikorab, everyone, Khanam also, the answer has been very pakka, perfect. The answer which we have been got it, no, that's been 90, that's been 90. I think it's the right time to move ahead, taking few more number of transfer function, and there also agenda is gonna be pretty very same. We are been focusing over the angle which would be offered by those system, Agreed? Let me take the next question, and the question do come in this way. It's been 1 plus s minus 1 plus s, and this has been the transfer function. How much angle would be offered by this system, which I would like to know now. How much angle which would be offered by this system? संतन सर क्यों मजा ले रहे हो? Santan sir is there. He's just taking enjoyment of mine. Anyways, tell me how much angle which would be offered by this system. The transfer function is being defined as the multiplication of the two factors. The first factor has been 1 plus of s, and similarly the second factor has been minus 1 plus of s. See, anyways, the calculation has to be performed over the frequency domain, so I think it's right time to map the value from the s domain to the omega domain, or simply I can say the s has been replaced with the j omega. If we have been doing so, what would happen? 1 plus of s has been j omega, and here it becomes minus 1 plus of j omega. And obviously again it had been a simple identity which we have studied in the class 9th, and that had been, what had been? A minus of b. So j omega had been a, and similarly 1 had been b. So simply it's going to be a square minus of b square. A square minus of b square. So the a square is simply going to be, how much it has been? A square is simply going to be j omega, which has been raised to the power of 2, minus of 1 square. Once you'll do so, no, you yourself would be able to understand it had become minus of omega square, and it had been minus of 1 square. What's the conclusion we can retrieve out of it? My dear friend, for the positive as well as negative value of omega, one thing is been quite sure, the minus of omega square would always be a negative quantity. Now the negative real quantity is again getting subtracted with 1, put together, this result would be always negative and real in nature. And as it has been negative and real in nature, at least again one important conclusion you could have retrieved. Let me draw the S plane. Here goes the S plane, real axis, imaginary axis, and it had been kept over the negative real axis. Yes, and here if the value had been pure real, that means it has to lie over the real axis, and its worth is being negative, it has to lie towards the left hand side of the real axis. This point could be anywhere depending on the different values of omega. Let's take the omega is being taken 0. Let's take the operating, if frequency has been very low, or you can say hypothetically it had been DC operating frequency, there omega would become 0, and as omega is becoming 0, you would be lying yourself at minus 1, and as the value of omega would be increasing, this point would be keep shifting towards left hand side, but still one thing has been quite sure. Either you take the reference of this, everywhere. If you take the angle from the positive x-axis, positive sigma axis into the anti-clockwise direction, you had made one thing sure, the angle had been 180 degree. Many of the students would also have one doubt, sir, should I be writing 180 or should I be writing minus 180 here? It's your choice. Mathematically, if you take the rotation anti-clockwise, obviously the measurement would be taken positive. If it is being taken clockwise, the measurement is being taken negative. So you can write plus minus 180. I have seen many of the times a student asks, sir, the best most answer should be plus 180 or minus 180, or in GATE examination also the answer would be either plus or minus, because they had been very same. They had been very same. See, this was the manual method. This was the manual method, but I would suggest to each one of you, focus over the method which we have been using so far. You can calculate the angle which would be offered by 1 plus s, and similarly you can calculate the angle which would be offered by minus 1 plus s, and you just had to add them together. And that's the beauty behind the transfer function, angle offered by the transfer function. Once you know the angle offered by this factor of the transfer function, what you can do, you can add them together. Agreed though? So may I know what had been the angle which would be offered by the 1 plus s? So imaginary part is been omega, and similarly real part had been 1. So from the trigonometric ratio, the angle which would be offered by the first factor is been tan inverse omega. And similarly, if I say the angle which would be offered by minus 1 plus of s, you yourself would be able to understand, minus 1 plus of s, what it had been 180 minus of 45, there it would be 180 minus of tan inverse of omega. So the result what we are supposed to get over here has been, here. So here it's gonna be 180 minus of tan inverse of omega, and this is going to knocked off. So choice is yours, whether you want to use the manual method, whether you want to use the method where we can assess the angle offered by the each and individual terms which are being involved with the transfer function, and we can add them together. In the same sequence, let me take the next question. Here goes the next question. Should I go forward? Yeah. Let me take the next question. The question had been, I need to get the angle offered by, let's take 1 plus s, and let's take 2 plus s. How much angle would be offered by this system? And from this system, I would like to know one thing. The angle, would it be positive or would it be negative? In future, we will see if the angle offered by this transfer is found to be positive. That means the type of transfer function it had been phase leading type of transfer function, phase lead in nature. The network is gonna be phase leading in nature. Otherwise, it's gonna be phase lagging in nature. Tell me, 1 plus s, 2 plus s, you would be categorizing the angle offered by this system under the leading in nature or lagging in nature. The same process has to be followed. May I know what exactly the process which we wanted to follow over here? So here starts the solution. So the angle offered by 1 plus s is simply going to be tan inverse imaginary part divided by the real part. And because of 2 plus s, what's going to happen? 2 minus of s has to get multiplied towards numerator as well as denominator. So one thing has been quite sure, the factor which had been coming into the picture has been 2 minus of s, and because of 2 minus of s, the real part has been positive, imaginary part had been negative. What's the angle which we would be offering? So angle is simply going to be tan inverse of omega divided by f2. And could you really understood or not? As the value of omega is supposed to increase, definitely this factor as well as this factor proportionally would increase. But here the factor had been omega and here the factor was omega by 2. That means at any operating frequency excluding 0, the value of omega, it would be larger than the value of omega by 2, and as the value of omega had been larger than the value of omega by 2, its tan inverse would be larger than the tan inverse of omega by 2. This factor or the angle which would be offered by this term would always be greater than this term, and hence the result would always be positive. It would always be positive. What does that mean of it? That means at any positive operating frequency, practically speaking, the omega would always be positive. For any practical operating frequency, this factor is going to be greater than this factor, and put together, one thing has been quite sure, that it would be always and always leading in nature. It would always be and always leading in nature. Leading in nature. May I know how we can change this leading nature of circuit to the lagging nature of the circuit? My dear friend, in future we would also be discussing about this thing into the control system. In case of first order leading network, the poles are being placed towards left hand side than the zeros. You yourself would be able to understand the 0 had been placed at -1, whereas the pole had been placed at -2. Could you understand what I am saying? Now I think it's the right time to take the next question. Here goes the question number 2. Here goes the question number 2. The component towards numerator and denominator, whatever we had earlier, no, now they have been swapped. Now they have been swapped. Now they have been swapped. It had been swapped to 2 plus s divided by 1 plus s. 2 plus s divided by 1 plus s. So I would like to have the input from each one of you. What do you expect from it? Would it lag or would it lead? Obviously, now it would start lagging. How did I know about it? The same process which we have followed earlier. Same process which we have followed earlier. It's simply going to be tan inverse omega by 2 minus of tan inverse omega. And this factor would always be lesser than this factor, and hence this angle would always be lesser than this angle. Or I can say the worth would always be negative. That means the phase which would be provided by this transfer function would again and always be lagging only. Would always be lagging only. So I would say it's been a type of lagging network. It's been a type of lagging network. So again, the next conclusion which we can retrieve out of it's been, just a minute. What it had been? If you locate the pole is being located at -1 and the 0 is being located at -2. 0 is being located at -2, it's been real axis, it's been imaginary axis. It's been real axis, it's been imaginary axis. It's been imaginary axis. One of the important conclusion which we can retrieve out of it's been, whenever you have the first order lag network, the pole would always be the dominant one in compare with the zeros. In compare with the zeros. Agreed, no? So I think the concept must be getting cleared to each one of us. To each one of us. In the same sequence, let me move forward and let me take the next question. Here goes the next question. Which color? This color I am be choosing. Let's take the next question. And the question is been, s plus 1, s plus 2, s plus 3, s plus 4, what would be the angle offered by the system? What I say, what would be the angle offered by the system? Let's take a certain operating frequency where the operating frequency is being fed as, let's take omega is equals to 1 radian per second. So pick your calculator and try to get its best most answer. How much precise angle would be offered by this system? That had been my problem. That had been my problem. Similarly, in the same sequence, let me take the next question. Here goes the next question. Let's take it's been the second question. Little bit amendment in this problem is being introduced. May I know what it had been? It had been s plus 1 getting multiplied with the s plus 2 towards denominator side. Let's take we had where it gone? Yeah, we had minus s plus of 3 and here we had s plus of 4. How much angle it's going to have? At omega is equals to 1. At omega is equals to 1. let me have the solution of the first. So here starts the solution. The angle offered by the s plus 1 is simply gonna be tan inverse imaginary part divided by the real part, which you have seen why it happens so. And now this factor had got multiplication. We have seen in case of complex variable, the angle which would be offered by this and this would get linearly added together, and here it's gonna be omega by 2. See, s plus 3 could have been written as you will take its for what? You will multiply with its complex conjugate. So here it would become 3 minus of j omega is get multiplied numerator and denominator. 4 minus of j omega would get multiplied at numerator and denominator. May I know how much angle would be offered? Obviously, because of 3 minus of j omega, angle which would be offered is simply gonna be how much? Minus tan inverse of omega divided by 3, and here is gonna be tan inverse of omega by 4, and end of the day, as per the problem, the omega has to be fed as 1, and you will be getting the angle which I supposed to get over here. So Khanam is saying 39.093. So obviously the angle which we are supposed to get, it's been 39.03. May I know what would be the angle which should be offered by the second question? The same process we are going to use here also. May I know which process has to be followed? Because of s plus 1, because of s plus 2, the same process has to be followed. Because of s plus 1, there would be the phase shift in the terms of tan inverse imaginary part divided by the real part, that's gonna be omega itself, and then tan inverse, here it becomes omega divided by f2, In the same sense, if we'll talk about the s plus 1, it would be tan inverse omega by 4. May I know what would be the effect of minus s plus 3? Again, the complex conjugate has to be taken place, no, as I have communicated earlier. Because of minus s plus 3, what it becomes? 3 minus of j omega. Once you will take its complex conjugate, it would go towards the upside and it would get multiplied as a 3 plus of j omega. And if there had been the multiplication of the 3 plus j omega, how much angle would be offered by it? And that being known to me, it would just be additive in nature and simply gonna be tan inverse over omega by 3, and this has been the outcome. How much angle we have been getting? Excellent Khanam. According to the Khanam, the answer which we have been getting out of it has been 75.93 degree somewhere. So what I am saying, in future, be ready. Probably the magnitude would not be your sir dard. The angle is gonna be the actual crux or actual pain, at least over the Nyquist as well as Bode plot. So until and unless you do not have the little bit idea how the angle is being calculated, the different kinds of the transfer functions which we have chosen, so definitely you guys would be in big trouble, big pain. Could you really understood what exactly I wanted to communicate through this complete? So in the same sense, what we are going to do over here, let me proceed further and let me take few more number of transfer function, and I expect you guys are now well acquainted to find the angle which should be offered by the individual transfer function. You can ask if you guys are having any sort of doubt in between. You can ask over here. Tell me any sort of doubt you guys are having, you can definitely ask the problem. If you guys are having any sort of doubt, you can raise your doubt. Let me focus over the standard second order system, which used to be k times of omega n square. Forget about the k, because if the k is being positive, no introduction of the angle because of that positive k. S square 2 zeta omega ns plus of omega n square. And if I would like to know how much angle which would be offered, just a minute, how much angle which would be offered by this system, may I know what would be your answer? How much angle would be offered by this system? And that's quite easy. How to locate the infinity angle is in plane. My dear friend, What does that mean by the infinity? Obviously, your omega must be trying to go towards a very large value, must be trying to go towards very large value. You yourself would be able to understand. If the omega would go to the very large value, it would become pi by 2, it would become pi by 2, it would become minus pi by 2, it would become plus pi by 2. Put together what had been happening, this pi by 2, this pi by 2 is going to knock off, pi by 2 and pi by 2 is going to get add up. Definitely the steady state, or I would say the higher most value of omega at which the system is been operating, how much angle would be performed? Obviously the angle which would be given, it's simply going to be 180 degree. It's simply going to be 180 degree. Anyways, when we would be discussing about the Nyquist plot had been drawn over the polar plot, had been an extension of the polar plot, but is still the omega starts from 0 and goes till infinity, Tell me how much angle would be offered by this system. How much angle would be offered by this system? How much angle would be offered by this system? So tan inverse of omega t by alpha. Anyways, this would be your homework, and I expect everybody would be able to calculate it well. You had to follow the same manual method which we have followed earlier, the same manual method. What you had to do, you had to segregate its real as well as imaginary part. If required, you had to take its complex conjugate, you had to multiply it, numerator as well as denominator. End of the day, what would happen? The real part as well as the imaginary part would get segregated. Once the real as well as the imaginary part got segregated, easily you would be able to locate the value of A and B. Once the A and B is done, precisely you would be able to locate the angle which would be provided by the system. So I think today's class I would like to bind up here itself, and the next thing which I would like to communicate to all of us, tomorrow I won't have any session. Probably many of the sessions we are not going to have in tomorrow. Specifically control system, I am not going to have my session, and the student who had been appearing for the engineering services examination tomorrow for the first paper as well as second paper, all the very best from my side as well as from the team of GATE Academy. All the very best, do well. All the very best, do well. I will not have my session of control system tomorrow because I would be busy on the complete sequence of the complete solution of the EAC examinations which we are bringing. Keep in mind, do not forget to tune in our GATE Academy channel precisely at 6 p.m. where we are going to have the discussion over the technical part of the question paper. Either it's been electrical, either it's been electronics. Agreed now? So this is all for the today's class. We are going to meet probably day after tomorrow. Till then, bye-bye, take care, all the very best. Bye-bye.